structure and all of those things. So my name is Dixon. So I am working as a technical lead and architect in few consulting companies, and I also train people on HL7 FHIR and Mirth Connect. So I also worked on various integration engines like Rhapsody, Mirth Connect, Integration Buddy, Connector, and Ensemble. Little bit on Cuvera and other integration engines as well. But predominantly, I worked on Rhapsody and Mirth Connect a lot. So from the past 12 years, I am working in this healthcare industry, especially in this integration space where we have to integrate one or two applications and make sure that we are using healthcare data standards to transact the data between these systems. Alongside, I am also training resources from the past 7 years online, specifically in HL7 version 2. And we have started FHIR batches 4 or 5 months ago. So that FHIR training can be done. And we also conduct corporate trainings as well. So we have completed a few batches in FHIR, few batches in HL7 V2 from corporate training perspective. So as part of our session today, we'll take a look at the basics of FHIR, which you may already be aware of, but we'll just cover quickly run through the basics of it and see about the where did we get this name, a little bit history about FHIR, and we'll also talk about the resource structure and all. One quick question, Alvin. So every one of you are working on FHIR from past 6 months or just a couple of them?
No, just a couple of them only for working in FHIR. Few people working some other technologies. But we need both are learn FHIR, so we can start with a scratch. It will be help us for all.
All right, let's do that. So we'll start from basics so that the others wouldn't feel left out. All right, so before starting, Alvin, you guys have exposure with the entire hospital workflow, or you guys started working in in hospital workflow in healthcare from past 6 months only?
Yes, we have exposure only for the past 6 months, and we don't have any hospital exposure.
Okay. So then let's discuss about workflows as well. So usually I start from hospital workflow because that is the base for everything, where the data gets generated or where the data gets started. So when we talk about hospital workflow, we'll quickly run through what is the basic workflow of the hospital in terms of an outpatient visit. Then we will jump on to see what are the things that we can get or understand from this workflow. So whenever we have any patient walking in, they will walk to the receptionist desk or the front desk staff and get their demographic information registered with the receptionist, right? So demographic information consists of patient's first name, last name, date of birth, gender, SSN, or any Aadhaar number or any marital status, address. All the basic patient details are considered as patient demographic data. So we use the term called demographics in healthcare. Once the patient demographic data is captured and saved in an application called PM application. So within hospital, you have this application called as PM application, which is nothing but practice management system. Okay. This application usually used to manage the administrative aspects of the hospital, like saving patient details, scheduling appointments, and manage the billing, and all of these aspects. All of the administrative related aspects will be taken care with the help of that particular software. Okay, and this software is used mostly by receptionists and the administrators. That is the reason it is called as practice management software, because it will help us to manage the practice. Then you have another software called as EHR, which is electronic health record, that is being used by the doctors, and electronic health record is used to manage the clinical data of the patient. So entire clinical data like allergies, medications, conditions, problems, diagnosis, and all, This will be present with the hospital electronic health record system. Okay, so there are two applications that we are ending up with. One is PM application used by the front end staff, and the second application is EHR application used by the hospital doctors and clinical staff. Now, when the demographic data that is registered in the PM system, it has to be sent over from PM to EHR. So we'll have interfaces or bridges that will actually communicate or carry the data from PM system to EHR system. How that is happening and all, it is based on a concept of having an interface between PM and EHR. We'll talk about that later down the line. For now, all that we need to know is the data that is saved in the PM system will flow over to the EHR system. Okay, once the demographic data is sent over from PM to EHR, next is where the appointment will be sent over from PM to EHR system. So as soon as the receptionist takes the details of the patient, they will schedule an appointment for the patient, right? With certain department and certain doctor. That information will flow over from PM to EHR. Next, once the appointment is scheduled, patient will go ahead and meet the doctor. And once he meets the doctor there, he will discuss about the problem that he has. This situation where the patient is meeting the doctor and discussing about the problem is called as an encounter. Okay. So earlier the appointment is scheduled. Now the encounter is happening for that particular appointment. That's how you see the resources in FHIR as well. You will see patient resource, appointment resource, and encounter resource. Right? Each one of them indicating different event that is happening in the real-time world. So once the encounter is done, during the process of encounter, if the doctor is able to determine the problem of the patient just by looking at the patient or by determining the symptoms, well and good. But usually that is not the case. What happens is doctors will go ahead and place a test order like blood test or thyroid test or some or the other test. So they will perform that test and send the patient to the lab to get that test done. So doctor is placing an order for that particular test. Once the result is generated, the lab will go ahead and send the result back to the HR system. Doctor will be able to look at that result and then respond back with that result to the provider or the EHR system. Then doctor will go ahead and take care of all the review the results and provide the prescription to the patient or perform certain procedures based on the final diagnosis. Right? Once that is done, the charge information that is needed will be generated from lab and from the EHR system and all, and that will be sent back to the receptionist so that the receptionist can go ahead and collate them all together and send the claim to the insurance company. That is where the entire workflow concludes, from the point where the patient walks in till the point patient leaves and the hospital gets their bill settled with the insurance company. This is the general outpatient workflow. But if we jump into inpatient workflow, there will be a lot of other things that will be coming into play, like capturing allergies, capturing medications, capturing daily vitals, and all of these additional aspects will come into play if the patient is admitted to the hospital. In case of emergency department, it's a different ball game altogether. So there will be other things that will come into play in terms of emergency healthcare department. All that we need to do here is always relate back to the real-time workflow scenarios to understand the data sets very well. So if you go back to the real-time scenarios and try to understand where in what scenario we are using certain data or uh, certain resource, if you determine that, then it will be easy for us to understand what is the content of that particular resource. Okay, now let us look at the problem statement on why FHIR has come into existence. Now we know that the data is consolidating in EHR. Demographic data is coming from PM to EHR and that is being saved there. appointments data is coming over, diagnosis information is saved, vital data, allergy data, and labs data, pharmacist data, everything is being saved into the EHR system. So there are various entities who will actually send the data to the EHR system. But unfortunately, patient himself, who is the owner of that actual data, doesn't have access to this information, right? The data is present with the hospital, and hospitals don't expose this data to the outside world. And that is where the major challenge comes into play, because patient is the actual owner, and he says that he won't be able to see it. He won't be able to see his entire clinical data or entire clinical trial, what happened over a period of time. Few organizations try to solve this problem with the help of providing a patient portal where patient can log in and take a look at few of his details and few of his appointments and all. But that is not a full-fledged solution, right? So that is where FHIR has come into play. So FHIR solved this problem by adding a FHIR layer in front of the EHR system. So what does that do? We usually call it as a FHIR facade layer, which means you will add a FHIR server on the top of your EHR database that you have and expose the internal data that is present in the EHR database to the outside world in the form of JSON objects, which we call as resources, either JSON or XML or Turtle. The format, it may have different formats based on the user discretion. But at the end of the day, we are exposing the data of the EHR that we have to the outside world, so that outside world can develop mobile apps or desktop apps to access the patient data and provide the patient the flexibility to access his own information that is present in the EHR within the hospitals. Okay, so this is where FHIR has come into play. And not only that, there are many other reasons FHIR has come into play, like the increase in the demand for the data that is there in the EHR system, demand from the patient side that they should also have access to the data, and so that they can have their overall clinical history uh, in their uh, in their hands. So this is one of the solutions that FHIR has provided. This was one of the major problem where the data is not being exposed out. FHIR enabled that concept of exposing the data. Okay. Along with that, you have other solutions which are opted in the healthcare industry. This is a generic solution, or this was one of the problem statements that has to be solved. They have solved it with the help of FHIR. We have advanced solutions as well, where EHR do not want to expose the data by themselves to the outside world. Okay, let's say we have a big hospitals like Apollo hospitals. They are using a product called as MedMantra, and they have their own application, which is MedMantra is a complete PM EHR application. They are storing the data. When you go to hospital, you have the data with them. They are saving the data information in their MedMantra application and all. But this data is not exposed outside. Okay, they can either add a FHIR layer, which will expose the data to the outside world, so that other people can develop various mobile app solutions and then deploy it with that particular application. This is what we are seeing right now on the screen. They can also do another thing. They don't want to expose their EHR data directly from their premises. Okay, which means they don't want the FHIR layer to interact with their database internally. Usually this is the case with big hospitals where they want to be secure, and they don't want others to get into their network at all. Okay, at that point, what people usually do is they go for the second solution, which is to create a FHIR repository. Okay, so what happens in case of FHIR repository? They transfer the entire data that they have in the EHR database to FHIR repository, and this can be stored in the FHIR database, which may be a relational database or no relational database, like Mongo or SQL database. It can be anything. And you will have a FHIR layer on top of that DB, which will actually go ahead and execute the FHIR transactions. So then from there, the data can be transacted in the form of JSON or XML, and then patient can have access to the data. So the only difference here is, in the earlier case, the EHR itself is the data source to expose the data to the outside world. In this case, EHR is creating separate repository altogether, or the hospital or the business entity is creating a separate repository altogether, which will store the data in the form of FHIR resources and then expose the data to the outside world. So what are the advantages of this? FHIR servers needs to be available all the time. Okay, because mobile apps are interacting with these resources or these data sets that they have, and hospitals have to maintain that in case if they have the FHIR layer or FHIR facade layer within their premises, right? And they have to make sure that database availability is there always to the outside world, and they have to maintain their network standards so that no attack happens. So there are many things that are overhead to the hospital. Instead of doing that, hospitals prefer moving the data to a FHIR repository, like especially on the cloud, like Azure or AWS or Google Cloud, and then uh, have them take care of everything or every aspect of security and all, and expose the data to the outside world. So there's a second solution. So most of the FHIR solutions that you are going to see will fall in one of these two categories. Okay, you may be developing a mobile app. May I know if you guys are developing a mobile app or an application app? I don't want the company name and all other details, but just wanted to know whether it's a mobile app you're working on the client side or the server side. Alvin, Ajit, are you guys with me?
We are working from server side.
Server side. So developing a FHIR layer, is that what you're doing? Receiving the data in the form of JSON and then or whatever it is.
Receiving the data as a FHIR bundle, then we are validating it, and when we are cleaning it, and we are making a centralized FHIR database.
Okay, okay, okay. So you're developing that entire solution, FHIR repository solution.
Yes.
Okay, all right. So yeah, so you are doing this part of the FHIR on the server side. So as I said, most of the implementations would fall under any one of these categories. So I just wanted to understand what exactly you guys are doing. So why do we need FHIR? So as I mentioned earlier, the HL7 organization usually defines the interoperability standards for healthcare. And in 2010, they have realized that there is a lot of real-time data, and this data has to be accessed by most of the systems out there. Right, like we need to have patient engagements as part of MU. We also need the mobile apps to interact with the FHIR resources and all. Sorry, with the healthcare data and all. And they felt that these things are lacking, and that is when FHIR has come into play. And they saw that we need to have a new standard which can go ahead and perform all of these three tasks. And FHIR is a standard that is purely based on all the previous standards of healthcare. What are the previous standards that we have? We have HL7V2, HL7V3, HL7CDA. So all of these three standards are combined together to generate or give birth to FHIR. So a lot of good concepts of these three older standards have been taken and incorporated into the FHIR. At the same time, if there are any bad uh, experiences or any bad concepts within these resources, they made sure within these standards, they made sure that they are not repeating the same mistake here in the FHIR. So FHIR that way is a very good enhanced and optimized data standard because it takes all the better features of the older versions that we have. So FHIR stands for Fast Healthcare Interoperability Resources. So as the name suggests, resources is the main key here. Everything in FHIR revolves around resources, right? So we use the latest technology of REST APIs for transacting data between the mobile client applications or any other clients with the FHIR server. And FHIR consists of resources, as I just mentioned. Everything will revolve around resources, and resources are called as basic building blocks of FHIR. And you can see that the entire healthcare data can be transacted in the form of FHIR. Whatever data you have within the EHR system, all the data can be transacted or can be exchanged in the form of FHIR resources. So let's look at the history of FHIR. So when you look at the history of FHIR, you have it from 1997. HL7 V2 started back in 1980s, but the standards have exploded a lot, and a specific standard was released in 1997. So HL7 V2.3 was released in 1997 as an official version. And after that, HL7 V2.5 was released in 2003. So this was an upgrade to the HL7 version 2. And then you have version 3 and CDA, which was released in 2005. And then you have HL7 FHIR R3 that was released in 2010 to 2016. 2016 was where R3 was released, and it is called as STU, which is standard for trial use, which means we were evolving from 2010 to 2016 and 17 at that during that time frame. Okay, most of them were drafting the FHIR resources and creating FHIR repo pages, and all of those things were happening during 2010 to 2016. The main kick-in started in 2019, where the entire world started looking at FHIR, implementing FHIR. Not that it was not there before that, but once R4 is introduced, a lot of people started using FHIR. And from 2019, we are seeing a lot of FHIR implementations. Okay, and that is a little bit brief. We have R5 around the corner, so that may be released. Apparently, it was supposed to be released by now. But we may have that coming up in future, or maybe by December or early next year. You will have the next version of FHIR released by the HL7 organization. So that is something that you have to keep in mind if you're developing a FHIR server layer. Just make sure that you are making it flexible to be used both by R4 and R5. Okay. So let's look at the 4 paradigms of FHIR. So the 4 paradigms are number 1 is REST APIs. So these are 4 categories that FHIR is planning to have. FHIR has planned to have. Currently, we are working explicitly on REST APIs. That is how we are exchanging the data between 2 different systems. But FHIR also concentrates on exchanging documents through REST APIs itself, but it wants to have the document exchange as a separate section, and then messaging exchange for supporting V2 and V3 type of transactions in future. And then you have services based transactions. So through this training, we are going to focus mainly on the REST APIs because that is one which is being used heavily right now. But in future, you may be using documents and messaging as well. Some development work is going on, and specification drafts are going on for these 2 things as well, but not explicit. I mean, they're going in parallel, not as fast as the things going on for REST APIs. So now we are talking about resource, and lot, right? So let us see what is a resource. So a resource is the basic building block of the FHIR standard. So the way we have functions in our programming language, which we call as basic building blocks, functions or classes. In the same way, where FHIR is a data standard. Okay, FHIR will tell you the format of the data that has to be exchanged between two different applications. That is all. Right. So when you talk about FHIR as a specification, it is achieving this aspect of data standard in the form of resources. So there are many resources in FHIR, and each resource is called as the basic building block of the FHIR standard. So what is a resource? When you consolidate smallest unit of data, which makes some meaningful sense out of it or meaningful information, if you are collating some data elements, combining together and making some meaningful information out of it, such smallest unit of data is called as a resource. Okay, so examples are like patient data, encounter data, observation data, service request data. So these are data sets that you will be seeing in the EHR repository. Let's take EHR repository. In EHR, there will be a lot of data sections, right? When the patient data is being saved to the EHR, you'll have allergies data, you'll have medication data, you'll have vitals data, you'll have order data, results data, and discharge summary data. So there are a lot of data sections that are available in the EHR module. So every data module or every data set that is there in the EHR should also have a corresponding resource data in FHIR. Okay, so all of these data sections are small data units, and every data set is represented in the form of a FHIR. So you can assume that, let's take a quick metaphor or example to understand what is a resource. So let us assume that we are applying for a job, and while applying for a job, we will have a form, right? And that form will ask you to fill your name, details, address, phone number, email address, and all. So you have dedicated fields in that form stating that fill your name here, fill your last name here, fill your first name here, and all, right? So that form, one single form, can be considered as one resource. Okay. In that way, you may have many papers in that form. It's not just one page that you'll have. You may have many forms. One form to grab your basic details, another form to grab your education details, another form to grab your uh, employment details if you have employed anything. So we are talking about three different forms here, right? Each form focusing on certain category of data. First form focusing on your basic demographic information. Second form focusing on your education information. Third form focusing on your employment information, right? So if you take one form out of it, let's say you take the educational form, you will understand that this is education information. These are the education details. But when you do not combine it with the other forms, it doesn't make much sense, right? Uh, so that's the reason we say that one resource might not give you a lot of information, because it will be making a meaningful sense when that resource is combined with other main resources only. So in this case, in the example that we are seeing, if you just pull out the education form and see, you will understand that these are education details of some person, but you will not know which person it belongs to and in which context it is being used. So you have to combine one or more resources together, or one or more forms together, to get complete meaningful sense or complete functional aspect or functional understanding of the data set that you are dealing with. Okay. Now we have talked about three different forms, filling the data in that form. What if we are not filling anything? These are empty forms, right? You will not have any information in those empty forms when you receive it for the first time. And that empty form will clearly tell you where to fill your last name, where to fill your first name, where to fill your address, phone number, email address, and all. So this form that you're seeing is same for everyone. Whoever is going to fill up that form, everyone will have the same structure. Okay, and that is called a standard, right? Telling that this is the structure of the form, and we call it as a form template, because that is a template that is being used all over the world, whoever wants to apply for that particular job, right? So these templates are nothing but FHIR resources. FHIR specification will define these templates, which is nothing but will tell you what all the data elements should be part of certain resource. Let's take patient resource. If you take patient resource, you'll have many data elements within that patient resource. What are the data elements that should be involved in that particular patient resource, and what is the structure of each element when you are working with that patient resource will be explained with the help of the resource specification, with the help of FHIR specification. So as I said, one single resource may not make much difference. You have to combine one or more resources to form a meaningful sense out of it. Okay, then let's talk about resource existence. So you have many things. You can use a SQL database, NoSQL database. SQL databases like Oracle, Postgres, SQL Server. You can use NoSQL databases like Mongo. It doesn't matter what database you are using. Obviously, people have various choices to have better performance, but the resources will always be present in the database. Okay, if we have patient resource, we have all the patient resources, and we have something called as a term called as resource instance. Now when you talk about a resource generically, it means you are talking about the resource structure and the generic template or the generic structure of a resource. A resource instance is a filled up form. If you're talking about an empty form where you see the structure, it is the resource, and we call it as a resource specification. If you talk about a filled up form, which means you have filled up the patient data or filled up one specific demographic information in there, then that is called as an instance of that particular resource, because you're talking about one specific patient record, you're talking about one specific demographic information, right? So FHIR specification will tell you the structure. Using that structure, you will create resource instances in the FHIR repository. Okay, and whenever you are having these resources will have a unique ID associated with it, which we call as resource ID. Usually we refer to this as logical ID. Okay, and this logical ID will be helpful for us to go ahead and identify that resource in the database. So these are like primary keys of the database table if you are using a SQL DB. Okay, now let us take a look at resource structure. So when you look at the resource structure, I'm just displaying the patient resource structure. When you look at the patient resource structure, you will have the elements displayed on what all elements will be part of the resource, and every element will be associated with a data type. Okay, and that data type will tell you what should be the structure of that particular element when we want to transact that element in the form of JSON or XML or turtle. Okay, one important thing here, we will stick to JSON because that is what is being used overall. So I might not use these terms XML and turtle down the line. So most of the times we'll be talking about JSON objects only. So when we want to transact a patient resource, what should be the structure of patient resource is completely defined by the HL7 FHIR specifications. Okay, and In that specification, they will specify what all the elements we have, and each element giving a rise to uh, more number of descendants, and that is determined based on the data type that we have. So for now, all that we need to understand is within the resource we have elements. Each element is associated with a data type, and this data type will tell you what should be the final structure of that particular element. Okay, so we have something called as complex data types and primitive data types. We'll talk about that down the line in upcoming sessions. So this is how the data looks like in the form of a JSON structure. So the entire data is divided into 4 different sections. The first section will represent the ID and metadata information. This ID is nothing but the logical ID using which we'll be able to uniquely identify each and every resource. Okay, and then you have the narrative section. Narrative section is nothing but XHTML data that is present in the database. This is used by the browsers to interpret the data and show it up in the systematic format. Then you have the extensions. Extensions are nothing but additional elements that you want to add to the basic FHIR resource. So usually when you look at the FHIR resource structure, you will have limited number of elements. And down the line with your specific implementation, you may feel that I want to add new elements to it. For example, as we can see here, birth date. Birth date, if it is not there in the basic FHIR specification resource, then I can go ahead and add it as part of an extension. Okay, that's what extensions are for. And the fourth section that you have is the actual raw data, the standard data for FHIR resource. So this example is for patient, and you can see that we have basic patient details, phone number, date of birth, gender, value, and all in the resource. These 4 are present in any of the resources that you take. Any resource that you take, all these 4 sections will be present. Okay, and the one that you see in the first section is called as part of the base resource, and then you have something called as domain resource. Domain resource, and then the fourth section that you have is called as the actual resource. Actual resource will have all the basic data elements that are needed for the demographics, and then the actual resource will derive its structure from domain resource. Domain resource will derive its structure from base resource. Okay, so these 3 are interrelated with each other to form a complete JSON object that is transacted by FHIR repository. Okay, so base resource, domain resource, and the resource will have their own structures. We'll talk about base resource, domain resource, and all tomorrow. So we'll conclude today's session here. We'll continue tomorrow because I have to join another call at 10 o'clock. But from tomorrow, we'll take it from 9 to 10. So I'll open up for questions. Any questions from anyone?
Diction, actually, I have a clarification.
Yeah.
Like, how can we split what are all base resource and what are all domain resource and what are all?
Yeah, we'll look at that tomorrow. We are going to look at individual structures of each of these base, domain, and normal resource, and understand what are the elements that will be part of each of these resources. We are going to take a deeper look at each of those elements.
Okay, fine.
So after that, you'll be able to see, say what elements are part of base, what elements are part of domain, and all.
Yeah, okay. That's it.
Yep. Any other questions from anyone?
No.
All right. So we'll conclude today's session here. We'll continue tomorrow with the rest of the topics and we'll progress with that. All right, guys. Thank you so much. You all have a very good day.
Thank you.
Thanks.
Thank you. Yeah.